Hello guys, this is Tronics Energy. Welcome again to this channel. If you have not subscribed, please subscribe. Today we are going to do this project. It's a new and more improved light detector circuit. I had done one before, but this is much better than the previous video of light detector. So this is the schematic diagram. You can pause and take a screenshot or anything. We'll go ahead and check the requirements here. So these are the requirements that you're going to need. We have 330 ohm, 10k port meter, 5.6, 5.6. We are not all going to use this the requirements. I'll show you on the breadboard, but the most important ones are these integrated circuits, LM393 or LM358, whichever you have, and I see TC74HC U04P hex inverter. We're just going to use one of the inverters. The single pole switch is not useful. You can just assume that it's not there. I'm not going to use it. So let's begin. So this is this is a schematic diagram, and our breadboard is here. I've already placed the LM358. You can use 393, whichever you have, but make sure you check this schematic diagram for the data sheet of the integrated circuit. And this is the TC. This is the hex inverter. We're just going to use one of the inverters. There's a video I've done about how to use this hex inverter. I'll put a description below and the link for you to get that video. So let's begin. We're going ahead to place the power supplies and the ground of these integrated circuits for us to start doing the other parts. So pin number 8 is the VCC, so we're going to place there, and then pin number 4 is the ground. So we're going ahead and take a pin to use for the ground. We go to TC74. Pin number 14 is VCC, so we place and pin number 7 is ground, so we take the ground pin that is not entering there. Now once you're done, now we can start with the circuit. We're going ahead and start working on this part of the circuit. This is the sensor. LDR is a light dependent resistor. You can shop these online or go buy them in the nearest electronic component shop. So this is the sensor. So first of all, you're going to make this voltage divider, then we're going to connect it with the sensor. Now the voltage divider will use 1k and 1 kilo ohm resistors. So from the power supply, like that, and then we're going to connect this part to ground. Just gonna take good. Now we take the sensor and connect it between the two resistors to go to the base of this transistor. So this is our sensor. We place it between and then the other pin goes to the base of the transistor, the NPN transistor. So you're going to take your NPN transistor. I'm using a 2N222. You can use a BC547, whichever you have. So just place it somewhere on the breadboard like that. So our transistor from VCC, there's R5 to the collector pin there. So this resistor we're going to check R5 at 10k. Okay. We're going to take the 10k, use the 10k, and from VCC then we connect that part of the breadboard. So from VCC 10k to the collector pin of the transistor, then the base pin, the middle pin, this sensor. So we'll take another jumper from the other pin of the sensor to the base of that transistor. Now we are remaining with one pin not connected. Now this pin, the emitter pin, we connect it to ground. So yeah, the emitter pin we connect it to ground. So that's the circuit. Now we are done with this part. Now remaining part, before the transistor from VCC, before the transistor, we'll have to place a jumper to connect to our first comparator on the integrated circuit. So we'll take a jumper wire, connect it from that point, the collector, to pin number 3 of the LM, pin number 3, like that. Then the pin number 2, we are going to connect our port meter. So let's connect our port meter. I'm using a 10k port meter. You can use a 20, but not above 20, just use 20 and below. So one of these 4 pins, we are going to connect it to VCC. This other pin connected to ground, and the middle pin connected to pin number 2. So once you've placed it, now we connect this first one to VCC. Connect it to VCC. The other pin we connect it to ground. I'm going to use a white one. Connected it to ground. Now the middle pin will connect it to pin number 2 of the integrated circuit. So pin number 2 goes to the middle pin, like that. Now this we are going to adjust it, make sure that it works properly. Now the output of this integrated circuit, the output of this comparator is pin number 1. So we'll take the pin number 1 and jump it all the way to one of these inverters. So just go ahead just go ahead and take a long jumper. Don't know if this is not going to fit. Need a long jumper like this one, and then you jump into pin number 1. Pin number 1 of the inverter. Pin number 2 will be the output of this inverter, so pin number 2 will go to LED. So take this from pin number 2 somewhere on the breadboard, and then we're going to connect the LED from this part. I'm using a blue LED. You can use any color you wish. Now, after connecting the LED, the other pin, the negative pin of the LED, goes to ground. So we take a 1K, 1 kilo ohm, and connect it to ground like that. You can check. This is the inverter. This is the inverter. After the comparator, inverter, then goes to LED, then goes to ground. So that's the circuit. I think we are done. Now we need to connect these two parts, the negative to this part. Did a long jumper. This is enough. Gonna connect it together. Like that. Now I think we are done. When we are good to go. Needed to turn off the camera light for us, make sure that it's not interfering with the results we are getting from our sensor. So we're going to place the pins that we are going to connect the power supply. So that's for positive and that's for negative. Using a 9-volt power supply, go ahead and connect the positive, and we connect the negative and see what happens. Yes, so yes, not doing anything. Let's adjust it. Okay, yeah, I can see now it's responding. Once something is blocking it from the light, it will turn off the LED, and you can do this at any range.